My dear students, we are going to discuss very important essay type questions of thermodynamics, Carnot's heat engine, and the second one is the differences between heat engine and a refrigerator. Now, the first question is explain reversible and irreversible processes, describe the working of Carnot's heat engine, obtain the expression for its efficiency. In my degree days, it was a 20 marks question. We'll try to derive the expression for efficiency in a shorter way. Heat engine is something that converts heat into work. So all our automobile engines are heat engines. They take petrol, they burn it and they give the heat. That heat in turn does some mechanical work. That is the definition of heat engine. Now, why should we take Carnot's heat engine? So, Carnot's heat engine is an ideal, a gold standard heat engine. We compare the efficiency of Carnot's heat engine with all other engines. So, it is a theoretical engine, it does not exist in practical. So, Carnot's heat engine consists of 4 parts. The first one is heat source. So, it is an ideal heat source whose temperature remains constant all the time even after supplying infinite quantity of heat energy. So, it can supply whatever the heat you want. The heat supplied by it is taken as Q1. So, it is a reservoir of heat which continuously gives heat, but its temperature remains constant. The second one is sink, or it is also called as cold reservoir. So, it is a reservoir which takes heat. So, how much heat it takes? Q2, and its temperature remains constant, T2. Ideal reservoir, it takes heat all the time, and T2 is definitely less than T1. This is the second part. The third part of it consists a working substance. What do you mean by working substance? Working substance is nothing but 1 mole of ideal gas. 1 mole of ideal gas enclosed in a cylinder having a piston. So, this is 1 mole of ideal gas conducting base. Only from this end, only from this side, heat can enter or heat can leave the gas. The fourth one, thermal insulating slab or a sheet. So, in Carnot's heat engine processes, there are 4 processes. One is isothermal expansion. What is isothermal? A process in which changes in pressure and volume occur at constant temperature. So, this is isothermal expansion. So, this gas expands. When it expands, it is placed on the heat source. So, this gas takes heat, the piston moves up slowly so that the temperature remains constant. So, that is isothermal expansion. The second one is adiabatic expansion. What do you mean by adiabatic expansion? So, during adiabatic expansion, I place it on a thermal insulator. So, because of the previous energy, it continues to expand further. So, in this case, heat remains constant. And the third one is isothermal contraction. Isothermal contraction. Now, I place it on the sink. So, I remove this thermal slab and I place sink. So, and slowly compress the piston. So, I am compressing the gas very slowly so that its temperature remains constant. So, T2 is constant. In isothermal processes, temperatures are constant. And the fourth step, once again I place it on the thermal insulating slab, a rubber slab for example. So, what happens? I further push the piston. So, this is adiabatic compression. So, how many processes are there? 4 processes. So, this question starts with what do you mean by reversible process? So, this Carnot's heat engine is an ideal heat engine where a reversible process takes place. What do you mean by reversible? Opposite of this is irreversible. So there are two types of processes, reversible. I start at point A and I go in this way. If I am able to come back, to the same position, that is called a reversible process. For example, take ice. You heat it, it becomes water. If you heat it, it becomes gas, that is nothing but vapor. And you cool it, then it becomes water. That means you are going in the same path. Water. You cool it further, it becomes ice. So I am going from ice to vapor, then vapor to ice. So this is called a reversible process. Process which can be retraced back is called through the same path, which is called a reversible process. A process which cannot be retraced back is called irreversible process. For example, burning coal. When I burn the coal, I will get the ash. Ash cannot be converted into coal once again. So that is an irreversible. All these processes can be represented by a PV diagram. A diagram drawn between pressure and volume. So I start at this point. So let us take this as A. Ideal gas undergoes thermal expansion, then adiabatic expansion, then compression, then coming back. So this A, let us say coordinates P1, V1, T1. This is isothermal expansion. Next, so coordinates of B are P2, V2, temperature remains constant T1. And here adiabatic expansion. So point C, this is P3, V3, temperature falls, temperature decreases in adiabatic expansion because I am not supplying any external heat energy. So from year to year, this is isothermal compression. So these parallel are same, isothermal, these parallel are adiabatic compression. Now let us say coordinates of this graph are P4, V4, temperature remains same because it is isothermal. This is T2. This is the coordinates of this point. Now I am going back. So I am coming in this way and reaching the same point. So this is an ideal reversible process. So the work done in isothermal process. So work done is nothing but W1 in the first process. This is the first process. This W1 is nothing but Q1. Q1 is the heat supplied by the source. Because of this heat energy only, work is done in expanding the gas. So this is given as RT1 log to the base E V2 by V1. Next, in second case, let us say this is equation 1. Next, in second case, we are doing adiabatic expansion. So the work done in adiabatic expansion is given by R by gamma minus 1, where gamma is Cp by Cv. R is gas constant into T going from T1 to T2. So T1 minus T2. This is equation number 2. Work done in the second process. Work done in the third process. Here work is done on the system, not by the system. So you will write minus, right? So work done. This is the work done in isothermal compression. The work done in going from C to D. This is from C to D. This is from A to B. And this is from B to C. The work done on the system while going from C to D is given by W3. So W3 is in the same way, I write it here, RT2 log, I am going from V3 to V4. So V3 by V4 to the base E. but I should take it as minus. This is minus RT2 log V3 by V4 to the base e. So if I take minus, it will become RT2 log V4 by V3. The work done in the last process going from D to A, that is adiabatic compression. The work done in adiabatic compression is given by, so W4, even this is also minus, so W4 is equal to R by gamma minus 1. Initial temperature is T2, final temperature is T1. When I add all these, so the total work done is equal to W1 plus W2 minus W3 minus W4. So these two will cancel, that is adiabatic processes works done, these two will cancel. So you will get it as, so this second isothermal expansion is nothing but Q2. First process A to B is by placing it on heat source. This is the first one. And in the second case, from B to C, it is placed on thermal slab. So this is insulating slab, insulator. Next, third process going from C to D. So this is placed on sink. So sink takes Q2. Here source gives heat energy Q1. Is this clear? Next, in the last process going back D to A, so this working substance placed on insulator. The work done is nothing but Q1 minus Q2. This will be equal to RT1 log E V2 by V1 minus RT2 log, this will be V4 by V3. So I am rewriting the work done once again, equation for the work done. So W is equal to Q1 minus Q2. In adiabatic processes, so in isothermal processes, the equation followed is PV is equal to constant. This is for isothermal processes, for any isothermal process. For adiabatic process, the equation is TV to the power of gamma minus 1 is equal to constant. And another one is PV to the power of gamma is equal to constant. So we have two adiabatic processes. One is here, the other one is here. So here I am going from T1 to T2. Here I am going from V2 to V3. Here I am going from T2 to T1. Here I am going from V4 to V1. So apply this. T1 V2 gamma minus 1 is equal to T2 V3 to the power of gamma minus 1. This is one equation. For this one I can write it as T2 V4 to the power of gamma minus 1. This is equal to T1 V1. You divide them, rearrange them, then you will get as V2 by V1 is equal to V3 by V4. This you are going to get. This can be written directly from these two equations, rearranging these two. If you rearrange these two equations, you will get this one. So from this I can write W will become RT1 log V2 by V1 minus RT2. Instead of writing V3 by V4, I can write V2 by V1. So this is my new equation for the resultant work done by the heat engine. Now what do you mean by efficiency? Efficiency is given by eta. Eta is output by input. You are doing some work. How much output you are getting for what input you have spent. The output of this one is work done. You are by using a heat engine, the final result is to do some work done. Input is the heat supplied. So that is Q1. So efficiency can be written as W, work done. Work done is this one. R, this is equal to Q1 minus Q2 also. R T1 log V2 by V1 minus R T1 log V2, sorry, R T2, this is T2, log V2 by V1 divided by Q1. Q1 is also same, R T1 log V2 by V1. So if you take log V2 by V1 common, this will cancel. This will cancel. R will also cancel. So you will get it as T1 minus T2 by T1. This is nothing but 1 minus T2 by T1. This is the final expression for the efficiency. You can also write it in terms of heats. Eta is W is Q1 minus Q2 divided by Q1. Same formula in terms of heats, 1 minus Q2 by Q1. This efficiency is always expressed in terms of percentages. So there is no heat engine in the nature whose efficiency is 100%. So getting 100% efficient heat engine in our real life is impossible. So if you write this much, you will get 8 marks. Dear students, we will discuss the second essay type question of thermodynamics. This is simple when compared to the previous question. This question does not involve any derivations, formulae or any mathematical jugglery. Now what is the question? State second law of thermodynamics. How is heat engine different from refrigerator? So there are two things. So one is heat engine and the second one is refrigerator. Now before going to this, let us discuss second law of thermodynamics. So there are 4 laws in thermodynamics. One is called zeroth law. The second one is called first law of thermodynamics. Third one is called second law of thermodynamics. The fourth one is called third law of thermodynamics. The second law of thermodynamics is given by 2 statements. One was by combinedly Planck and Kelvin. So one statement is called Planck-Kelvin or Kelvin-Planck statement. Remember it as KP, Kelvin-Planck statement. And another statement is given by Clausius. So Clausius statement. So these are the 2 statements. In nature, there is no process in which total heat can be converted into total work. So in the nature, you don't find any process. By doing any process, it is impossible to convert the total heat energy into total work. But the reverse is possible. Total work can be converted into total heat energy. So there is no heat engine which is having 100% efficiency or which is converting the total heat into total work. It is impossible. So most of the heat is wasted. It is given to the nature. So heat is lost. For example, I spend 100 rupees of petrol, then I will get only 40 rupees of work. The remaining 60 rupees is wasted in the form of heat that is given to the surroundings. Wasted. That is the Planck or Kelvin-Planck statement. So Clausius statement says that heat always goes from high temperature to low temperature. So heat never goes on its own from low temperature to high temperature. So this is done by applying some work. External work is done to pump the heat from low temperature to high temperature. So this is heat can be pumped. So it is called heat pump. So heat pump works only when you supply some external energy. This heat pump, another name of heat pump is called refrigerator. So how a refrigerator works? So refrigerator is nothing but an enclosure in which in summer the outside temperature is 50 degrees Celsius. I bring an apple something and I'll put it inside. The temperature of the apple is also 50 degrees. As soon as I keep it in the refrigerator, its temperature is 50. But I want to cool the apple. So what I have to do? I have to draw the energy, heat energy from the apple, and I have to give it to the environment, surroundings. So once I decrease its temperature, now it becomes 40. Even at 40 also I am not satisfied. I want to make it 20. So I am pumping, reverse pumping the heat to the outside 50 degrees Celsius atmosphere. So this is called refrigerator. This is the functioning of a refrigerator. Let us go to the differences between heat engine and refrigerator. So first you have to write about heat engine. So what does a heat engine do? Heat engine converts heat into work, mechanical work. What does a heat pump? So heat pump is nothing but refrigerator. What does it do? So refrigerator pumps heat from low temperature to high temperature. So what does it consist? It consists heat reservoir at heat energy Q1 at temperature T1. So this is source of the heat, or it is called a reservoir, source of the heat. So from this we draw heat energy Q1, and this heat energy is taken by some working substance. That was in Carnot's heat engine, working substance. What does it do? It gives some heat Q2 to the reservoir, that is the cold reservoir, or it is also called as sink. The remaining part of the heat is converted into work. So your work done by the system. In a heat engine, heat is taken from the source, little bit of work done, the remaining heat is given to the sink. So I am coming from upper level to lower level. I am doing some work. So this is heat engine. The reverse of heat engine is heat pump. The reverse of heat engine, very, very important to remember this. So I will draw this same diagram. So this is sink at Q2, temperature is T2. So heat is drawn from the object whose temperature is less, because T2 is less than T1. Heat is drawn. How much heat is drawn? Q2 is drawn. How can I draw the Q2? In order to draw the heat energy from the objects of lower temperature, I have to do work. So external work is done. External work is done on the system. So this is our system. So this Q2 and the work done W are added to the environment. This is hot reservoir. How much is given? Q1 is given. So what can I write? I can write Q1 is equal to W plus Q2, or W is equal to Q1 minus Q2. So these are the differences. So you have to write at least 5 to 6 differences. What are the other differences? Let us see. In the case of heat engine, efficiency, eta is equal to output by input. So what is the output? Here the output is work done. What is the input? I am drawing heat Q1. Note it as Q1 minus Q2 by Q1. This is nothing but 1 minus Q2 by Q1. Or it can be written as, in terms of temperatures, eta is equal to 1 minus T2 by T1. This is in the case of a heat engine. So coefficient of performance, it is called coefficient of performance instead of efficiency. Coefficient of performance. It is indicated by beta. So whatever you take, the formula will be same, output by input. Now what is the output? So my intention of refrigerator is to draw heat. This is my final work. This is my aim. So this aim is my output. This I want to perform. I want to draw heat from the colder object. So for this, the input is, I am giving only W. So this is my input. So this is my output and this is my input. Now let us go. So output is Q2. This is my intention. This is W. So beta can also be written as Q2. Eta cannot be greater than 1. This is impossible. Because if you want to make it at least 1, these two must be equal. When they are equal at equal temperatures, heat cannot travel. So work cannot be done. So having efficiency of heat engine greater than 1 is impossible. But beta can be greater than 1. That is coefficient of performance in the case of a refrigerator can be greater than 1. The two diagrams you have to define, you have to write the formulae related to them. Then you will be getting 8 marks. Thank you.